Now that we know what our extreme values are, we're going to look at how to find them. So we're going to start out with some examples. We're just going to find the critical points, and then we're going to take them and apply them to our maximum and our minimums. So starting out here, to find the critical points are where the derivative equals 0 or the derivative is undefined. So I'm going to start by taking the derivative here. This is going to give me 3x squared minus 12x plus 9. And I want to know when this equals 0. So I'm going to set my derivative equal to 0. I'm going to start by factoring out my 3 here. And I'm going to factor that a little bit further. So I'm going to get x minus 3 times x minus 1. So what x values make this derivative function equal 0? That's going to be 3 and 1. So these are my critical points on this curve. They could be maximums, they could be minimums. We would have to test to see that out. The way that we can figure out if they're maximums and minimums is plug them back into the original function and get those y values. So here, I could quick plug in 1 minus 6, negative 5, plus 9 is 4, plus 2 is 6. And if I plug in 3, that's 27 minus 54, which is negative 27, plus 27 is 0, so I get 2. Well, if everything else is playing out okay, that means this is going to be my maximum, and this is going to be my minimum. These are going to be local because these graphs go forever. Okay? All right, what about this guy? So again, I'm going to start by taking the derivative. So I'm going to get low d high minus high d low over low squared. So simplify that out. I'm going to get x minus x. So I'm going to get negative 1 over x minus 1 squared. Low d high minus high d low. Yep. All right. Well, in this case, this derivative will never equal 0 because my numerator is 1. In fractions, the numerator has to equal 0 to equal 0. So this will never equal 0, but what about if it will be undefined? Undefined is when the denominator is 0. You can't even see what I'm writing down there. So what I have, 0 over a number is 0, or a number over 0 does exist. That's our undefined that we're looking for. So in the denominator, if I plug in 1 minus 1 gives me 0 in the denominator. So that is our only critical point. But if we take that back to the original, can I even plug that into the original? Not going to happen. So what that tells me, this doesn't have any critical points. So we're not going to see any maximums or minimums. Interesting. Okay. Last example over here, we'll take a look. It says find the absolute max and min. And I didn't even put the problem up there. So let's write that down. Okay. We're going to be looking at the function 1 minus 6x plus x squared on the interval from 0 to 4. That's better. Here we go. All right. So first thing we need to do is we need to find our critical points. So I'm going to take the derivative. So I'm going to get negative 6 plus 2x. And now I'm going to set it equal to 0. That's going to give me 6 equals 2x. X equals 3. So I want to find my absolute min, my absolute max. My absolute minimums and maximums could be the endpoints. So what I'm going to do is I'm going to build a t-chart here. And I'm going to plug in the x's, and I'm going to find the y values. I'm going to use my critical point and my endpoints. So I'm going to plug in 0, 3, and 4. So if I plug in 0, I'm going to get 1. If I plug in 3, that's going to give me 1 minus 18 plus 9. It's going to give me negative 8. And if I plug in 4, I'm going to get 1 minus 24 plus 16. That's going to give me negative 7. So from here, 1 is my highest number, so this is my absolute maximum. And this 3, negative 8 is going to be my absolute minimum. Yeah? Okay, those numbers are going to change and the functions are going to change. They're going to get harder. The algebra is going to be different. Just take a look. Your steps are the same. We're going to start by taking the derivative, finding those critical points, and then testing them to find if they're absolute mins or absolute maxes. If you got questions, let me know.